Hello all, welcome to Excel Academy. So today we are going to make a video on the topic that is Z transformation, that is the problems and ROC. So my question is, that is what I can say, the x of n is equal to what? Here x of n, I'm sorry, just a second, I'm sorry. So that is that is the x of n is equal to what? X of n is equal to, that is what I can say, that is 7 into 1 by 3 to the power of n, that is u of n, that is u of n. So let me take like this. So here, yes, so that is minus what I can say, that is 6 into 1 by 2 to the power of, that is n into u of n, right? Yes, n into u of n. So this is what is my required. So what is my question? So my question is, that is 7 into 1 by 3 to the power of n into u of n minus 6 into 1 by 2 to the power of n into u of n. So very first thing what I have to do, is I have to take the x of z formula, right? So I have to take what? I have to take x of z formula. So if I have to take my x of z formula, so your very first thing is your x of z formula itself, isn't it? So your very first step is to take what? That is x of z formula. That is what is x of z formula? That is summation of what I can say. Your n is equal to minus infinity to infinity. So that is equal to what? X of, that is n into z to the power of minus n. Isn't this the formula? Yes. So now if I substitute the given x of n in the formula, I get n is equal to minus infinity to infinity. What I can say, that is 7 into, we have to put a bracket because that x of n gets multiplied to z to the power of minus n. So that is why I take, this is 7 into 1 by 3 to the power of n into u of n, that is minus 6 into, let me just slide it. Yes. So now it is what? It is minus 6 into, that is 1 by 2 to the power of, what I can say, the n into u of n, right? I guess you got it, right? This is whole into z to the power of minus n. So now I guess you got it. So what did we do? See here, we just substituted what? This particular. So what was that particular? This, that is 7 into 1 by 3 to the power of n into u of n minus 6 into 1 by 2 to the power of n into u of n was my x of n. That is the given question. So that I substituted over here. See, you can see here, right? So that I substituted over here. That is this particular, right? Yes. So now next thing what I have to do is I have to what? Just separate it. So what is the separation? The separation in the sense, you can see that there is a constant value, that is what? Your 7 and your 6 are constant values, right? So I am going to remove that. So how it will become? So and I am going to separate, I am going to provide summations for these two. So that is this one as well as this particular, right? So if I do that, what I'm going to get? I'm going to get that a summation of n is equal to minus infinity to infinity. What I can say, you're going to put 7 over here. So 7 is kept outside. So you get that is 1 by 3 to the power of n into u of n, right? And once again a of n into z to the power of minus n. So this z to the power of minus n, where it was? So see here, this z to the power of minus n was over here, right? It was over here. You can see this z to the power of minus n was over here. So the question is, that is x of n into, what I can say, z to the power of minus n. So z to the power of minus n gets multiplied to whole x of n. In the case of x of n, you had two terminologies. That is, one was 7 into 1 by 3 to the power of minus n into u of n, and one more terminology was 6 into, that is 1 by 2 to the power of n into u of n, and both was subtracted, right? So what we have to do after doing this particular? So we have to do is, we have to multiply z of into each of this, and we are going to remove the constant outside, the second thing. And what we are going to do is we are going to provide summations to this 1 by 3 to the power of n into u of n, as well as 1 by 2 to the power of n into u of n, right? Yes, so that is what we are going to do. So that one, if you do, you are going to get the resultant. So let me just showcase to you here. See, yes, so see here, yes, so z to the power of minus n, that is you have to take, that is minus what, that is your minus 6 into, that is what I can say, summation of n is equal to minus infinity to infinity, what I can say, that is your 1 by 2 to the power of n into, just a second, I just close that, yes, that is 1 by 2 to the power of n into u of n, what I can say, just a second, it is u of n, that is into z to the power of minus n, right? So now what did we do in this particular step? So that is in the step number, what I can say, this step, this step, what did we do was, the very first thing we did was what, the very first thing we did was, that is the first thing what we did, we removed constant outside. We removed constant outside. We provided summation to what? We provided, yes, 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 we, what did we do? We provided summation to both. That is what I told you, that is 7 in, that is what, 1 by 3 to the power of n into u of n, we, and 1 by 2 to the power of n into u of n. We provided summation to both, that is we provided summation to both, and what? We provided summation to both. And the third thing what did we do? And the third thing what did we do was, what I can say, what did we do? We just multiplied z to the power of n to both, z to the power of minus n to both, right? We multiplied to both, that is what we did, right? So I will just showcase you here. See, this is what is my required equation. And what did I do? What did I do very first? Yes, yes, what did I do? I just removed 7, that was constant, right? I just removed, that is 7 outside, did I? Yes. And what did I do? And what did I do? So here you can see, here I just provided summation for this particular, right? Summation for this particular. And what I did, I just multiplied this a to the power of minus n to this 1 by 3 to the power of n into u of n, right? Then what did I do here? Here if you see, there was a 6 as constant. I removed 6 outside. And here what did I do? I just multiplied z to the power of minus n to this, as well as I provided the summation, right? Did I do all this? Yes. So now I did all this. So therefore now what I have to do was, so now let me take the next step. Let me do my next step. So my next step would be what? So my next step would be, I need to solve individual ones. That is, first I need to solve, that is 1 by 3 to the power of n into u of n, and then 1 by 2 to the power of n into u of n, right? So how to solve that? So what, before that what I have to do? Before that what I have to do is, I have to see through, that is the summation, right? So summation, here you can see that your u of n is present, right? So to eliminate u of n, you know that what is u of n. Your u of n signal, what, it starts from 0 and ends at infinity, that is, it is a right sided sequence. So therefore what I have to do, I have to write my equation as, that is 7 into summation of n is equal to 0 to infinity, because it starts from 0 and ends at infinity. That is here what I can say, 1 by 3 to the power of n into, that is z to the power of minus n, right? And next what I have to do, I have to take, that is once again plus sorry, minus 6 into what I have to do, that is the same thing, that is n is equal to 0 to infinity. You have all done this procedure in the, what I can say, the very first problem, right? That is alpha to the power of which one, that is alpha to the power of n into u of n. You did right there also, you got a u of n and you just got to know what is u of n and you just change the summation, right? The same thing you are doing here, right? Here you get that is 1 by 2 to the power of, that is n into u of n, I'm sorry, not u of n, it is z to the power of minus n, because we just took the summation for u of n, right? Yes, this is what as we did. So now what you have to do, you have got this. So now what you have to do, in the very last two problems we have done the same process. Now we are going to do the same. That is what, you are going to remove n and we are going to make n as a power. So that is how, so that is equal to, you get it as, that is 1 by 3 into what I can say, that is 1 by 3 into z to the power of minus 1, that is whole to the power of n. I told you about z to the power of minus 1, right, in the last problems, that is this minus is associated with n. So therefore when you remove n outside, what is that going to happen is, so the thing that is going to happen is you are going to get it as minus 1, right? And now once again it is once again it is, that is minus 6 into, that is summation of n is equal to 0 to, that is your infinity. That is what you get that is 1 by 2 into z to the power of, that is minus 1, that is whole to the power of n, right? Yes, you got it. So this is what is the given. And now what did we get? So see here, you can see that we got it in the form of what? We got it in the form of the formula, that is formula is, that is summation of n is equal to 0 to infinity alpha to the power of n. So we'll use the formula now. So first, if you use the formula over here, you get it as, that is 7 into, that is what I can say here, 1 divided by, so that is, what is the formula of alpha to the power of n? That is 1 divided by 1 minus alpha if your alpha modulus is lesser than 1. So for the signal to converge, you have to it is like the alpha, that is alpha modulus of alpha should be lesser than 1, right? So this is 1 minus 1 by, what is your alpha? This one. So that is 1 by 3 z inverse. So once again I'll take it over here. So that is, you get it as, that is your minus what? Your minus, that is 6 into what I can say, that is 1 divided by 1 minus 1 by 2 z inverse. So let me do the simplification now. So let me multiply 6 to this and let me, what I can say, multiply, that is 7 to this. So if I multiply 6 and 7 to this, what I get? So I get it as, that is, you can see here, see, yes, you can see here, that is what I can say, this, it is 7 in divided by, just a second guys, you always, you need to write equals in the middle, right? 7 into, that is 1 minus 1 by 3 z inverse, that is minus, what I can say, this 6 into 6 divided by 1 minus 1 by 3 z inverse. So what I got, if I multiply 7, I get 7 divided by 1 minus 1 by 3 z inverse, that is minus 6 divided by 1 minus 1 by 2. This is, I'm really sorry for the disruption, it is 1 by 2 z inverse. And then, so next what you're going to do, you are going to simplify. So how do you simplify this? You are going to simplify, what you're going to simplify by taking this 2 as common. If you take this 2 as common, so what are you going to get? So you're going to get it as, so see, I'll take it. So see here, you get it as like this. So that is what? 1 minus 1 by 3, that is z inverse. So that is whole into 1 minus 1 by 2, that is z inverse, right? Yes. Just a second guys, I'll no. Just a second guys, I'll just, yes, push it over here. Yes. So it is 1 minus, what I can say, 1 by 2 z inverse. Right, you got it right. So now to get, so this particular, so if you consider this one, that is this 1 minus 1 by 3 z inverse, so what is that going to happen? So you are going to to get this particular, so you have to multiply this 1 minus 1 by 3 z inverse to 1 minus 1 by 2 z inverse, right? If you multiply to 1 minus 1 by 2 z inverse only, you are going to get the resultant, this particular resultant. So therefore for that, now let me multiply. That is what I can say. The just a second guys, I'll do the process now. So that is, let me multiply, that is 7 into, that is 7 into what I can say, the 1 minus 1 by 2, that is the z inverse, right? Yes. So now once again, if I take minus for 6, what I have to do, so say for 6 it is, just a second, I'll erase this, I'll erase this and I'll close this. Yes. So see here, for 6 what I have to do, for 6 what is here, it is 1 minus 1 by 2 z inverse over here. So to get 1 minus 1 by 3 z inverse into 1 minus 1 by 2 z inverse, I need to multiply 1 minus 1 by 3 z inverse to this 1 minus 1 by 2 z inverse. So therefore what I have to do here also to multiply the same. That is what I can say, 1 minus 1 by 3 z inverse, right? So yes, this is what is you get. And now my next thing what I'll get is, so see, I'll keep this as it is. So next what I'll get is, if I multiply, that is what I can say, this 7 into, that is 7 into 1 minus 1 by 2 z inverse, I get it what, that is 7 minus 7 by 2, that is z inverse. So 7, that is minus what I can say, I get 6 into, that is 6 minus 2 z inverse, right? 6 minus 3, I'm really sorry guys, it is 1 by 3, so therefore it is 6 by 3 z inverse. So that is divided by, that is what I can say, 1 minus 1 by 3 z inverse, that is 1 minus 1 by 2, that is z inverse, right? Did you get it? So I guess you got it. So therefore now let us move on to the next. So therefore now let me simplify this. So if I simplify this, how to simplify? Let me take this 7 minus 6 now. So if I subtract 7 minus 6, what I get? I get it as, that is 1, right? So minus, so if I subtract 7 by 2 minus 6 by 3, I will be getting it as 3 by 2, right? I guess you can do, right? 7 by 6, 7 by 2 minus 6 by 3, if you do, I get 3 by 2 z inverse, right? Z inverse is there, so you need to add that, multiply that, and along with you get it as 1 minus 1 by 3, that is z inverse, and 1 minus 1 by 2, that is, yes, 1 minus 1 by 2, that is your z inverse, right? Yes, so this is what is, you got it, right? So this is what is the resultant, and now let us convert this resultant in the form of Z transform, right? If I convert this in the form of Z transform, so what is for, that is 1 minus 3 by 2 Z inverse, it is Z into, that is Z minus 3 by 2. So that is for 1 minus 1 by 3, you get Z minus 1 by 3 into, that is z minus 1 by 2, right? I guess you got this, right? So this is what is the resultant, and you can see here that your x of z is containing, what I can say, the two terms. So you are going to consider this particular equation for that. So it is containing two terms, that is 1 minus 1 by 3 z inverse and 1 minus 1 by 2 z inverse. So if you want both the terms to converge, so what you have to consider is, you have to consider that, that is here 1 by 3 z inverse modulus should be lesser than 1. I already told you, for a what I can say, the term to converge, you need to consider lesser than 1 itself, right? And then here what I can say, here 1 by 2 z inverse, what I can say here, that is here 1 by 2 z inverse should converge, right? 1 by 2 z inverse, the whole modulus is lesser than minus 1. So now if I take, what I can say, the 1 by 3, yes, just a second, I'm really sorry for the distraction that is happening over here. Yes, so it is, if you consider, that is what I can say, the 1 by 3 z inverse. So if you consider, so you get it as, that is 1 by 3 into, that is 1 by z whole modulus, that is lesser than 1, or I can say that, that is your z modulus is greater than 1 by 3, And for the second one also it is the same. Here instead of 3 you write it as 2, and then there what is going to happen is you are going to get it as, that is your z modulus is what I can say, that is greater than 1 by 2. So now your ROC would be, this particular one will be your ROC. So that is region of convergence. So therefore let me take my region of convergence now. So according to my region of convergence, what I have got it as a right sided sequence, isn't it? So let me take another color here. So I'll take this particular color now. So I'll show it to you the region of convergence. So this is what, just a second, I'm sorry for the interruption. Yes, so this is what is my region of convergence. So what I have to draw, I have to draw a circle inside the what I can say, the z axis. So wherein it is centered at z axis, and this is what I can say, my real of z, and this is what is my imaginary of z, right? Imaginary of z. And then here what you can see, that you are going to shade it, that is outside the circle. So what is your ROC lies outside the circle. Yes, outside the circle, and your ROC is what, that is here you have to mark it and just mention it as, that is 1 by 2. Your ROC is 1 by 2, right? So this is what is your given particular question, and this is what is the answer. So let me brush it up again. So I'll go back and show it to you in an clear way. So let me showcase this one. So what was my question? So see here guys, I'll reduce this. Yes, just a second. Yes, I guess you got it right. Yes, I'll reduce this. Yes, yes, so you got it. Yes, just a second, let me align it guys. Yes, yes, so now what was the question? So my question was what? So my question was, so that is what I can say, my question was here, this thing, which one? My question was, that is 7 into 1 by 3 to the power of n into u of n minus 6 into 1 by 2 to the power of n into u of n, right? So what did I take? Very first I took this particular formula. So for whatever problem you get, you are going to take this particular formula. So here it is capital X. Yes, so this particular formula, what is that formula? That is summation of n is equal to minus infinity to infinity, that is x of n into z to the power of minus n, right? So now what did I do? I just substituted the whole x of n, that is this x of n, to here, right? That is what I wrote it here. And then what did I do? I did three things. What? I provided summation to this particular 1 by 3 to the power of n into u of n and 1 by 2 to the power of n into u of n, as given here, the summations, the two summations. And what did I do? I just removed the constants outside, and I just multiply z to the power of minus n to this one and this one. So see, did I do? I removed constant outside. 7 and 6 are outside. I provided summation to this 2, right? 1 by 3 to the power of n into u of n and 1 by 2 to the power of n into u of n. You can see that there is a summation, right? And then what did I do? Here for both I multiplied z to the power of minus n, right? So now what I have to do to eliminate u of n, what did I do? To eliminate u of n, what did I do? I just took this, change the summation from n is equal to minus infinity to infinity to, that is n is equal to 0 to infinity, right? It starts from 0 and ends at infinity, and here it is there, right? You can see, right? Yes, and here this is what is the resultant you get. Now what did I do? I just took n as a power. For that what did I do? I just did like this, that is you got it as 1 by 3 into z to the power of minus 1, that is whole to the power of n. So I just kept n as a power, so I just removed n here also and here also. So this thing I did here also, right? And then what form I got? I got this as in the form, that is x of summation of that is n is equal to 0 to infinity, that is alpha to the power of n formula, right? So I got this in the form of alpha to the power of n, that is this one and as well as this one. And what did I do is I just substituted like this. So what is this? This is alpha to the power of n formula, that is 1 divided by 1 minus alpha. My alpha was this, so therefore I just substituted alpha over here, and I did the same for this also, right? Here also I did the same. And what did I do? I just multiplied 7 and 6 over here. So I'll just make a alignment, guys. Yes. Yes. Still more upward. Just a second. Yes. So now what did I do, guys? So I just multiplied 7 and 6 here, wherein I got it, that is 7 divided by 1 minus 1 by 3 z inverse minus 6 divided by 1 minus 1 by 2 z inverse. And what I did, so I just did this particular, this particular process, right? I just took these two as common, and I just multiplied this with 1 minus 1 by 2 z inverse. Because why? Because for one, to get this particular resultant, so what I have to do is I have to for 1 minus 1 by 3 z inverse over here, that is present over here, I need to multiply, that is 1 minus 1 by 2 z inverse. So, and that one I multiplied it over here, and for this particular I need to multiply this 1 minus 1 by 3 z inverse, wherein I multiplied to this and I got this resultant. And I just simplified this, wherein I got this, and I also even wrote this in terms of z transform. And then next what did I do was, I just told that for this particular term to converge, so there are two terminologies, that is 1 by 3 z inverse and 1 by 2 z inverse, right? For this particular terms to converge, what I have to do, I have to take it less than 1. And so therefore I simplified this to particular, wherein I got it as what, that is your modulus of z is what I can say, the greater than 1 by 3 and 1 by 2 respectively. And I got to know that my ROC is z is, that is what I can say, the greater than 1 by 2. And so therefore I did my ROC. So how did I plot my ROC? I just draw a circle, that is ring inside the z axis, and then I just plotted ROC is equal to 1 by 2 over here. And then what did I do was, I just shaded the ROC was outside the circle, so that is outside the ring, right? Outside the ring, because my z inverse was greater than 1 by 2. So it is greater than is what? So greater than is a right sided sequence. So it was right sided sequence. So I had to shade it outside the circle. So this is what is the given problem. I guess you got it while explaining and even while revision. And we are going to meet in the very next problem. Thank you.